Hi, ladies and gentlemen. Notes 2.5 are on media statistics and probability. Just so that you guys remember, media means all forms of getting information. So TV, radio, social media, internet, books, all kinds of things like that are all considered media. So probability and statistics are presented through media in a variety of different contexts. You have three definitions that you guys are going to need to get down. For your three definitions, I want you guys to pause the video if it's going too fast for you to be able to write everything down. So the first definition is statistics, which is the collection and analysis of data. Okay? The second definition is, not definition, but the second part of our note we need to write down is that statistics are collected from real life events or studies. Okay? They're not just made up. And lastly, like probability, statistics help us to predict results of future events. Okay? So make sure that you get all this information down before you move on. So some examples of statistics. Right here, I want you guys to think of some examples of stats that you have seen and fill that in. Again, same thing, pause the video, and then come back to me when you've completed that. Okay? All right, so first of all, this right here should say favorite music stations, not movie stations. So if you could fill that in, that'd be great. And it says a local radio station surveyed, sorry, let me just X out of this. A local radio station surveyed 200 students from one high school to determine their favorite type of music. The results are shown in the table. So question A asks us to express each percent as a decimal and as a fraction in lowest terms. So it says that 45% of students prefer rock, 35% of students prefer rap, and 20% of students prefer country. So to be able to express each one of these as a decimal, for rock, for example, if it is 45%, 45% as a decimal is just 0.45. Okay, so that's our answer as a decimal. Now, as a fraction, it would be 45% is always out of 100, so we would divide by 100, or put it as 45 over 100. Now, to simplify, I'm going to look for what number are both of these numbers divisible by. And they're both divisible by 5. So when I divide them both by 5, I get 9 over 20. So that's the fraction in lowest terms of people who like rock. Okay? The next one is rap. So what fraction of people like rap? So we know that 35% of people like rap. So as a decimal, we know that's 0.35. Now, as a fraction, we're going to do 35 over 100, and we're going to divide both of those numbers by 5. Again, because they're both divisible by 5, so we get 7 over 20. Okay? And then lastly, let's do the same thing for country. So for country, we know that 20 out of 100 people like country, so they're both divisible by 20, so I end up getting 1 over 5. And as a decimal, that's equal to 0.20, or you could just say 0.2. Okay? So part B says, if there are 4,000 high school students in the city, how many of them would you expect to like each type of music? Well, if 45% of students like rock, we can take the 4,000, so we'll say this is for rock. We can take the 4,000 and multiply that by 0.45. Okay, and by doing that, we can figure out how many people like rock. So let's go ahead and calculate that. So 4,000 times 0.45, we know that 1,800 students like rock. Okay, now let's do the same thing for rap. So for rap, we're going to take 4,000 and multiply that by 0.35. So we'll figure out what that answer is when we multiply it, and we end up getting 1,400. So 1,400 people like rap. Okay, and then lastly, we have country, right? And for country, we know it's 4,000 times 0.2, or 0.20. So when I multiply that, 4,000 times 0.2, I end up getting 800. So 800 people like country. Okay? All right, so then part C, is it possible that the poll might not be accurate? Definitely. And what are some factors that could have influenced the response? Well, only 200 students were surveyed, so it was a small sample size. It was only one high school, okay? And there are a lot of other different factors that might have influenced this response. Okay, all right, so now the next example that we have here is statistics and probability. Okay, so it says all students at a high school were surveyed about 2 sports. The results are shown in the graph. Express each result as a decimal. So we're looking at students who like basketball, students who like football, students who liked both, and students who like neither. Okay, and in case you can't read these numbers, this is 190, this is 340, this right here is 565, and then this number over here is 100. So the first thing we need to do is find the total number of students that were surveyed, okay? So we're just going to add all of these numbers together. So 190 plus 340 plus 565 plus 100, we know that there's a total of 1,195 students. Okay, so part A says to express each result as a decimal. So let's go ahead and express basketball as a decimal. So for basketball, we know that 190 students out of 1,195 have chosen basketball, have said they like basketball. And we'll do this to the nearest hundredth. So when I divide 190 by 1,195, I get 0.158995, so on and so forth. To the nearest hundredths, we would get 0.16. So this answer right here is 0.16. Okay? Then it says that we want to figure out for football, what percentage of people like football. So this right here, we'll do 340 out of 1,195. And when I divide those two numbers, I end up getting 0.28. So that means 28% of the students said that they liked football only. Okay. Next is both. So to find what percent or what amount of students liked both, I would take 565 and divide that by 1,195. So when I divide those two, I end up getting 0.47. So that means 47% of the people surveyed said that they like both. And then for neither, we know it's going to be 100 out of 1,195. And when I divide 100 by 1,195, I end up getting 0.08. So 8% have chosen neither. Okay, so then part B, it says, what is the probability that a student chosen at random likes basketball but not football? So right here we know that 16% of people have chosen just basketball, so we can say the probability of basketball is simply 16%, and that's all I have to do. Okay, part C, what is the probability that a student chosen at random likes either basketball or football? So the probability of basketball or football but not both would be the 16% plus this 28%. And when I add that 16% to that 28%, I end up getting 44%. Okay? And then lastly, what's the probability that a student chosen at random likes basketball or football or both? So if we have probability of basketball or football or both, we just have to add 16%, because that's basketball right here, to the 28% for football, to the 47% for both. And when I add those guys together, I end up getting 91%. So this here ends up being 91%. Now, if you notice, when I add all of these probabilities together, they don't add up to a whole because of our rounding. Okay, and that's okay. It's not a big deal because they're pretty close to being pretty accurate answers. So another possibility that you could do is to find the probability of basketball or football or both is to just take the full amount, the 100%, and just subtract out who said neither, because everybody that's left over is going to be our answer right here. So that's 92%, which is still pretty close to our answer that we got here, and it's all because of the rounding. Okay? All right, that's it for the video. Let me know if you have any questions. Have a good day.